all of you are well. Let's start our today's class, which is Medical Chemistry First Paper Master Class on Chapter 3, Periodic Properties of Element and Chemical Bond. We are going to take Lecture 6. The topics that will be discussed here are hybridization of orbitals. What kind of questions usually appear in hybridization of orbitals? First, you may have to determine hybridization. You may have to determine hybridization of certain compound. You may also find out bond angle, which is very difficult to recollect if we do not practice more. Next, you may have to determine the shape of the molecule. Shape of the molecule. Related questions also come in admission test. And also, in case of complex ion, you may need to find out shape of the molecule, bond angle, determining the hybridization, as well as their color. Related MCQ may come. So hybridization concept, you need to have clear grasp on hybridization concept, and mostly you have to know how to quickly find out the correct option for hybridization. First of all, hybridization concept came because when electrons are shared between orbitals, then scientists thought that the orbitals should be of equal energy, otherwise the sharing of electron might get hindered. That's why the concept of hybridization came. Scientist Pauling proposed this hybridization theory and clearly stated that before sharing electron, equal number of orbitals of similar energy mixed up to form equal number of hybrid orbitals of equal energy. I mean, if 4 orbitals participate in hybridization, then 4 hybrid orbitals of equal energy will be participated, and their alignment should be in certain way so that the hybridization is possible. If we start solving the questions, I think we will be able to know the additional information that we need to know before solving the MCQs. As we can see, dental admission test in 2021 to 2022 session, there was a question about hybridization, and in medical admission test, hybridization related question appeared long ago. So it is very likely that hybridization related questions will be appearing soon or in the next admission test, because it is an important topic. Unfortunately, this topic lacked importance in medical admission test, but I think it won't happen later, because our majority of the chemistry questions in medical admission test are now coming from the exercise portion of our different writers. And in this chapter, the exercise related MCQs are mostly related to hybridization. So we don't have any chance or choice to skip this topic, showing the logic that it came long ago. Okay, first question, which one is the orbital hybridization of ammonium and phosphonium ion? This is the first question. It is asking that what will be the hybridization of phosphonium and ammonium. Okay, now we have to know how we can determine hybridization. One technique of determining hybridization is half into V plus M minus C plus A. Here H stands for number of hybrid orbital. V stands for number of valence electron, while M stands for number of monovalent atoms within the molecule. Also, the C stands for, the C is applicable for number of, not number actually, it is charge of cation. We will just place the digit only, nothing else. Charge of cation, and also with A, it will be charge of anion. Here we have 2 cations. So for this ammonium or phosphonium, what will be the hybridization? H equal to half. Since nitrogen and phosphorus are in the same group or belong to same group, so they do have equal number of valence electron, which is 5. So I am writing 5 for V. Here, hydrogens are the monovalent atoms. We have 4 hydrogen atoms. Again, these are cations. That's why I have to write one more digit here, which is 1. See, I didn't place any plus minus before 1. I just wrote what was there in formula earlier and only placed the numerical charge without their positive or negativity. I have written the digit only. And after that, it will be 0 because it is not an anion. So if we add it up, what will we get? We will get half into 8, which is 4. Number of hybrid orbital 4. It means sp3 hybridization. What does it mean? It means sp3 hybridization. So look at the options. There is the answer. Okay, so this is an approach to determine hybridization quickly, but sometimes you may fail to get a number that can explain its hybridization. Like if you got 7.5 or 2.5, then you would not predict what would be their hybridization. In such case, there should be another technique, and exactly there is another technique to determine the hybridization, which will be discussed in the upcoming question. If the central atom of a compound is hybridized as D3sp3, then what will be the shape of the compound? Let's consider this. This D3sp3 hybridized orbital have how many orbitals? 3 and 4, exactly 7 orbitals. For 7 orbitals, the shape would look like this. First, place 5 points in a pentagonal fashion. Okay, it is a pentagon structure, and place remaining 2 points, one at the top and another at the bottom. And now connect this structure, and you will find the shape. Look, here is the pentagon. Here is the pentagon. Now connect again, connect and connect. Okay, similarly I can connect them as well, and those which are left behind I can connect with a dot to show them that they are placed behind. So basically, if you think about the structure, then you'll find that it got 5 surface in the top pyramid and the lower pyramid. Both of them got 5 surfaces. That's why we can call them pentagonal bipyramid. We have a pyramid over here, we have a pyramid over there. Both pyramid got 5 surfaces. How they got 5 surfaces? Look, this is surface 1, which is in the front. This is surface 2. This is surface 2. Again, this one can be labeled as surface 3. This one can be labeled as surface 4. And in the back, at the back, there is the 5th surface. So it generates a pentagon, and a pentagonal pyramid is there. So pentagonal 2 pyramid can also be stated as pentagonal bipyramid. But you don't have to answer such questions by drawing their structure. It is quite easy to determine the shape just looking at their orbital number. What have I said earlier? I have said pentagonal bipyramid. For pentagon, you got 5. For bi, you got 2. So together, you got 7. Like square planar, since it's square, it consists of 4 points, right? It consists of 4 points. And now, if it consists of 4 points, then the answer should have been sp3, right? But if it is planar, then all the p orbitals cannot participate in this question, in this situation. For that, only 2 orbital is able to participate in the hybridization to make it planar in the same plane. It will lie in the same plane if only 2 exists of p orbital, on if the 2 p orbital of 2 different exists participate. If all the 3 gets participated, then it won't be any 2D structure or planar structure. It would become a 3D structure. So in this case, the hybridization could be sp2d, not sp3. Here, the triangular bipyramid, just count the numerical portion of the word. Tri and bi, if we add it up, then we get 5. So for 5, it can be sp3d or dsp3. Okay. For octahedral, actually, it does not require 6. It does not require 6. It does not require 8 points. It requires only 6 points for octahedral structure. How? Just think. 4 points in there, 4 point in the middle. Suppose these are the 4 points in the middle, and 1 point above, 1 point below. Now connect them. Now if we connect them, it would look like this. It would look like this. It would look like this. Again, we can connect them. We can connect them, and the line at the back can be joined this way, and they can be joined together in this fashion. So again, let's circle the points that we were talking about. How many points we got? We got 6 points. That means 6 orbitals. And for 6 orbital, you are getting 2 pyramids. 2 pyramids, but they got 4 surfaces. One at the above or at the top got 4 surfaces, and one at the bottom got 4 surfaces. So the total number of surfaces is 8. That's why the shape is called octahedron. And this is the octahedral structure. So octahedral structure can be obtained in case of 6 orbitals, which is sp3d2 or d2sp3. In this case, in this question, the answer is pentagonal bipyramidal. Let's move on to the next question. Here it is asked that amount of bond angle. Actually, what will be the bond angle of ammonia? What will be the bond angle of ammonia? This is the question. The answer is very known to us, which is 107 degree. 104.5 degree is of water. 109.5 degree can be of any structure with sp3 hybridization without any lone pair electron. On the other hand, 120 degree is for sp2 hybridization with similar condition without any lone pair electron. Why I'm mentioning this? Because once the lone pair electron gets come, then when there is more than one lone pair electron or one lone pair electron is available at the structure, it will cause repulsion to the bond pair electrons, which is stated in valence shell electron pair repulsion theory. And valence shell electron pair repulsion theory dictates that lone pair electron repels lone pair electron most, followed by lone pair repulsion with bond pair, and the bond pair repulsion is very least. But considering all these factors, the usual shape gets distorted and the bond angle gets deviated from the usual value. Anyway, let's move on to the next question, where it is asked that according to classification, which class includes the crystal of ice? The crystal of ice is shaped rhombohedral. This is something that is not included in our current book. Our current book rather asks about the number of hydrogen bonds within an ice molecule. Okay, we do not see such question or such information in our book, yet we do have to remember this because it once appeared in our medical admission test at 13-14 session. The rhombohedral shape is for ice. Which kind of hybridization occurs in the central atom of hexacyanoferrate? Okay, now this is a complex ion. For complex ion, how will we determine the hybridization? Here, number of hybrid orbital is equal to number of ligands. Okay, so we can see number of ligand is 6, so the number of hybrid orbital will be 6. For 6 hybrid orbitals, the hybridization can be sp3 d2 or d2 sp3. Now here comes the question, which one will be the answer, since both of them are present in the options. Here, the main information that you may need to know, that is the strength of the ligand determines which hybridization will take place. If the ligand is stronger, it is capable of shifting the electrons of 3d subshell. That would result into d2 sp3 hybridization. So I can write down this way that d2 sp3 hybridization is applicable for stronger ligands. But in case of weaker ligands, we will find sp3 d2 hybridization. Okay, so these are stronger ligands. These will be applicable for stronger ligands, and these will be applicable for weaker ligands. Now you may be wondering, what kind of ligand cyanide is? To determine the strength, I'm showing you or writing down the mnemonic that would help you to remember the strength order of ligands. This is halo, protidin, amine, এখানে কেমন করে? হ্যালো, প্রতিদিন আমিন এখানে কেমন করে? With halo, I meant halogens. What should be the order in case of halogen? We can write it down this way: fluorine, chlorine, bromine, iodine. Okay, so it is fluoride, chloride, bromide, iodide. For which ion it would be easier to provide that 2 electron? Certainly, it would be easier for fluoride. It would be less easier for fluoride. It would be much easier for iodide because iodine have a larger shell. Okay, this is the structure. After that, with this, I meant water. Water is a stronger ligand among the weakest ligands. Okay, this is stronger among the weaker ligands. Next comes ammonia, ethylene diamine. Ethylene diamine, also known as in short form EN. Cyanide, carbonyl. Now the order would look like this. So the one which are written in the white color are a bit stronger and the halogens are a bit weaker. For stronger ligands, since cyanide is in the upper zone, the strength of cyanide ligand is comparatively higher. That's why I can assume that the 3d subshell gets empty or gets the electrons of the 3d subshell moves away because of those ligands. That's why the answer would be d2 sp3 here, not sp3 d2. Okay, so you should all remember this mnemonic and the order according to the mnemonic to ace these questions in the exam hall. Okay, let's move on to the next question, which is the type of hybridization of central atom of sulfur dioxide molecule. You can determine the sulfur dioxide molecule hybridization in this way. Since sulfur got 6 valence electron and there is no monoatomic, no cation, no anion, so we can easily say that it is 3 and it will be sp2, right? But what is the other way that I was talking about to determine hybridization? To determine hybridization, you can get it from structural formula. You can get hybridization from structural formula. How? First of all, you have to know number of sigma bond. Next, you have to know number of coordinate bond. Lastly, you have to know number of lone pair electron to determine the number of hybrid orbital. If you can determine these three type of information from a structural formula, then you will be able to answer the question. Suppose sulfur dioxide. Sulfur dioxide would look like this, but as we all know, sulfur have 6 electrons in its outermost shell. So it shared 2 electrons with oxygen, 4 electrons with 2 oxygen, but 2 electron is still left as lone pair electron. So in this case, our first thing, that is the number of sigma bond, is equal to 2. And number of coordinate bond, there is no coordinate bond, but we have lone pair electron, which is 1. So the number of hybrid orbital is 3. So the answer is again sp2. So I have demonstrated the two approaches with which we can effectively determine the hybridization. This one is the ideal technique, but we do not recommend this because sometimes we don't even guess, or we can't even guess the appropriate structural formula of a molecule. In that case, or in times of emergency, in terms of quick responsivity, quick response moment, we have to go for the shortcut technique one, which is also mentioned in our main book. Which type of hybridization occurs in the central atom of xenon difluoride? Okay, now we will go for the formula. Half, as we know, xenon got 8 electron in its valence shell. We have 2 monovalent atoms which are fluorine. It is not a cation, it is not an anion. So the answer will be 5, and the 5 will be sp3d. Okay, sp3d. Again, you can determine the answer using this formula which I have taught just earlier in earlier question, which is first determine the number of lone pair electron, number of sigma bond basically. Here the number of sigma bond is 2 and the number of lone pair electron is 3. So total 5, and for 5 the answer will be sp3d. Anyway, here the answer is D, sp3d. Which type of hybridization occurs in graphite? In case of graphite, there is electrical conductivity because of sp2 hybridization. Here a delocalized electron travels between shells, which enables them to conduct electricity. Which one is the orbital hybridization of ammonium and phosphonium ion? I have already answered that. For ammonium and phosphonium, the answer is sp3. In which hybridization pi bond is formed? For pi bond formation, we do need to have at least a pure p orbital. In case of sp2, we have a pure p orbital left, which will help them to get bound with parallel overlapping or side-to-side overlapping. So the answer would be B. Which type of hybridization occurs in C atom or carbon atom in C2H2 compound? C2H2 is alkyne, which is ethyne. In case of ethyne, there is double bond. For double bond formation, the hybridization that takes place is sp. Okay. Even you can also determine the carbon hybridization using the formula that I have taught earlier, such as the number of sigma bond here for one carbon is 2, and there is no such thing called lone pair electron. So 2 stands for 2 orbital, and 2 orbital certainly forms a linear structure with sp hybridization. Which is not sp3 hybridized compound? sp3 hybridized compound have 3 elements. Look at the boron trifluoride structure here. If you look at the structure, you will find it easier since it got 3 sigma bonds, so the number of hybrid orbital would be 3, and here the hybridization would be sp2. Okay, so boron trifluoride do not contain sp3 hybridization, rather it shows sp2 hybridization. Rest of the structures, ammonia, water, methane, these are the classic examples of sp3 hybridization. We do not recommend you to determine their hybridization using any formula. You have to be that level of expert, you need to have that level of expertise to say that if I see ammonia, then yeah, it is sp3. If it is water, then it is sp3. If it is methane, it is sp3. You have to have such basic to determine their hybridization without any calculation or without any structure and all. Okay, you need to have that clear idea or memory, I should say memory, of their hybridization so that you can save your time in admission test. Which hybridization of carbon-carbon is present in ethylene? In case of ethylene, it is sp2 hybridization. In case of ethane, it is sp3. In case of ethyne, it is sp hybridization. What is the bond angle of water or water molecule? This is already known to us. It was supposed to be 109 degree, but because of having 2 lone pair electron, the valence shell electron pair repulsion theory states that the lone pair would repel highest. As a result, the angle gets changed and the shape gets distorted. Instead of the tetrahedral usual structure for the sp3 molecule, here we get a bent structure or the angular structure with an angle of 104.5 degree. Next question, which compound has the lowest bond angle? The compound which shows the lowest bond angle. For practice, I should write all the bond angles here. 104.5 degree, NCl3 would be equal to ammonia, so the bond angle would be around 107 degree. For hydrogen sulfide, the bond angle is 94 degree, and for phosphine, for hydrogen sulfide, it is 92 degree. For phosphine, it is 94 degree. Okay, so if we can memorize all these bond angles, you can easily answer the question. Here the answer would be hydrogen sulfide. Okay, which one below has the highest bond angle? Again, let's write down all the bond angles. For methane, since it is sp3 hybridization without any lone pair electron, so the angle would be 109 degree 28 minute, which is 109.5 degree. For ammonia, we already know this is 107 degree. For water, this is 104.5 degree. And for carbon dioxide shows a linear structure, right? For carbon dioxide, it is 180 degree. So they have asked about the highest bond angle. The answer would be carbon dioxide. What is the shape of nitrogen trichloride molecule? Remember that if you get number of hybrid orbital as 4, if the number of hybrid orbital is 4, then without what will be the shapes? For shape, first, without any lone pair electron, the shape will be tetrahedral. With, if one lone pair electron, the shape becomes a bit distorted. It is like deformed tetrahedron and looks pyramidal. The shape becomes pyramidal. If the number of lone pair electron becomes more, which is 2, if 2 lone pair electron is there in such shape or in such molecule, in that case, the shape becomes bent or angular or V-shaped. What happens if 3 lone pair electron comes? Then the structure may get linear. Okay, that's my whole point, how number of lone pair electron increases and the shape gets distorted. So in this case, for ammonium trichloride, the hybridization can be determined from this structure formula, which is sp3, but 1 lone pair electron is there, so the shape would not be a tetrahedral structure, it would rather be a pyramidal structure. The answer would be pyramidal. What is the shape of phosphorus pentachloride molecule? Okay, now let's determine its hybridization. Phosphorus pentachloride molecule have phosphorus at its central atom, which have 5 valence electrons. Here 5 monovalent atoms are also there, which is chlorine. This is not a cation, not an anion, so the number of hybrid orbital would be 5. For 5, we have already stated the shape would be 3 plus 2, which is trigonal bipyramidal. Trigonal bipyramidal. So 3 plus 2 equals to 5. Which is the correct sequence of bond angle? Here, as we can see, all of the atoms, I mean, these are the hydrides of a single group, which is Pnictogen group. You all know Pnictogen group is group 15. Group 15. If we write their order, it would look like this. Nodite pani ashe, shokale, bikale, majrate. With this mnemonic, we can easily remember all the members of the group 15. Here, if we look at their hydrides, like first hydride for ammonia, the bond angle becomes 107 degree. For next phosphine, the bond angle became 94 degree. So look at the trend. From top to bottom, the bond angle gets decreased. So we can assume that ammonia is the one who got highest bond angle. So placing ammonia at the front and keeping the order of the group same, I think we got the correct answer, which is option A. Which one is the correct order of bond angle? Here, a bit different scenario, because we do not have members of same group anymore. Rather, we do have some common molecules whose bond number needs to be memorized, or in fact must be memorized for appearing the admission test. If I write it down, for methane, the bond angle would be 109 degree, 28 minute. For ammonia, the bond angle would be 107 degree. For water, the bond angle would be 104.5 degree. And for hydrogen sulfide, the bond angle would be much less, which is 92 degree. So I think I have written them in the correct order. So answer will be this way. Okay. For first methane, then ammonia, then water, then hydrogen sulfide. What is the number of lone pair electron in xenon hexafluoride compound? Okay. To determine the lone pair electron, you have to determine the number of hybrid orbital. You need to subtract number of monovalent atom and number of divalent atom from them. Here, M stands for number of monovalent. I mean the atoms having valency 1. And with D, number of divalent atoms. Number of divalent atoms, number of monovalent atoms. Okay, number of divalent atoms, number of monovalent atoms. Okay. Number of, if I determine the lone pair electron for xenon hexafluoride, what will be the hybridization? We know xenon got 8 electrons in its outermost shell, and it got 6 monovalent atoms. So the number of hybrid orbital would be 7. So it is sp3d3 hybridization. Here, number of hybrid orbital is 7, number of monovalent atom is 6, number of divalent atom is 0. So the number of lone pair electron would be 1 pair. Okay, so the answer would be 1. Which compound has the highest number of lone pair electron? Here, if we demonstrate the lone pair electrons with dots, it would be easier to understand. For chlorine, we can see 3 pairs of lone pair electron. Again, for ammonia, we get 1 pair of electron in nitrogen. For oxygen, we get 2 lone pair electron. For sulfur, we have 2 lone pair electrons. So the answer would be A, hydrochloric acid. What is the reason for the distorted tetrahedral shape? Distorted tetrahedral shape. I have already explained the reason behind distorted shape of sp3 molecule. It is because of having lone pair electron, and it is explained with valence shell electron pair repulsion theory. So repulsion of bond pair with lone pair electron explains the bent or the reduced angle of ammonia and causing the shape pyramidal instead of tetrahedron. Which compound is linear in shape? Certainly carbon dioxide is linear. Xenon tetrafluoride is not linear. Instead, xenon difluoride can be linear. which of the following compound is not tetrahedral in shape? Carbon tetrachloride is tetrahedral in shape. Ammonium is also tetrahedral in shape because the lone pair electron of nitrogen was donated to hydrogen. That's why it again become tetrahedral structure. CH4 also have tetrahedral structure, but sulfur tetrafluoride will not have tetrahedral structure. Why? If I draw the structure, it would look like this. Sorry, it would look like this. Fluorine, fluorine, and also fluorine. Sulfur have 6 electrons, so it certainly have one lone pair electron left. Here the number of hybrid orbital is 4. No, here the hybridization is sp3d. sp3d, the shape was supposed to be for sp3d, I mean for 5 orbitals. For 5 orbitals, the shape was supposed to be trigonal bipyramidal. Trigonal bipyramidal. But here, because of this one single lone pair electron, the shape gets distorted. It becomes trigonal pyramidal, not bipyramidal. The bipyramidal structure does not happen in case of sulfur tetrafluoride because of that valence shell electron pair repulsion theory. Anyway, this is not tetrahedral in shape, okay, because it has a higher hybridization or higher number of hybrid orbitals. Anyway, let's move on to the next question. What is the hybridization of carbon atom in this molecule? Okay, this carbon have 3 sigma bonds. So the hybridization would be sp2. Again, in this carbon, we see 3 hybridization, 3 sigma bond, which is sp2. But for this carbon, here 4 sigma bond is there. So the hybridization would be sp3. So there is sp3, there is sp2. The answer would be C. What is the number of sigma and pi bond in this compound respectively? We have solved such questions earlier, but again, we are solving it. To determine number of sigma bond, you need to subtract 1 from the total atom. So the formula would look like this: total atom minus 1. Now you have to know, or you have to calculate the total atoms here. As you can see, there are 4 carbons and 6 hydrogen and an oxygen. Okay, C4, H6 and O. Okay, so total number of atom 11 minus 1 equals 10. So the number of sigma bond would be 10. Again, there is a pi bond, and for carbonyl molecule, there is also a pi bond. So the answer would be 10 2. What kind of hybridization is present in PCl5? Same, half 5 plus 5 equals to 5. We have already solved that, which is sp3d. How many sigma bonds are present in benzene? As we know, benzene got a ring structure. Having this molecular formula. So the total number of atom is 12. We have to subtract 1, and we have to add the number of ring. For closed cyclic compound, number of sigma bond is equal to total atom minus 1 plus number of ring or number of cycle. So the answer here would be 12. How many sigma bonds are there present in benzene? The answer would be 12. If there is no sigma bond mentioned here, if the question was like this, like how many bonds are there in benzene, then we have to add up the sigma pi bonds along with the sigma bonds, which would result into 15. What is the bond angle of beryllium chloride? This is a linear structure having sp hybridization. For this reason, the bond angle would be 180 degree. The upcoming question asks which one is the correct order of bond angle in silicon tetrachloride, boron trifluoride, and ammonia. Here, for ammonia, the bond angle is 107 degree. This is for ammonia. And for boron trifluoride, since this is sp2 hybridization, we will have a bond angle of 120 degree. And silicon tetrachloride, as of silicon tetrachloride, the structure would look like this. It is somewhat like carbon tetrachloride, but this structure already tells us its hybridization, which is 4. And for this type of structure, the bond angle is equal to 109 degree, 28 minute. So the order of the bond angle would be BF3 will be greater than silicon tetrachloride, and silicon tetrachloride will be greater than ammonia. So the answer here is B. Okay, let's move on to the next question. Here it is mentioned that in the ammonium ion, what type of hybridization occurs in the central atom? For ammonium ion, we have already determined the hybridization, which is sp3. Which one is impossible? sp3 is sigma bond. Sigma bond is possible in between any orbital, but only pure orbitals except s orbital is capable of forming pi bond. So pp pi bond is possible, sp3 is sigma bond possible, but any hybrid orbital won't be able to form pi bond because they lack symmetry. What is the bond angle of compound like AX3? If it is AX3, it can be ammonia, right? It can be ammonia having a lone pair electron. So in that case, the structure would result such bond angle. And again, it can be boron trifluoride as well. For boron trifluoride, the answer can be 120 degree. Okay, so this is a wrongly framed question. Just showing something AX3, it does not tell about anything. AX3 can be anything. Okay, so it can be NCl3, it can be NF3, it can be NH3, and also it can be BF3 as well. So the bond angle would depend on the exact atoms, or you have to at least give us any clue regarding A, regarding X. The answer can be both B or D. Okay. Anyway, in the book, the answer given is B. The next question, which compound contains sp hybridization? For sp hybridization, we can see the linear structure of carbon dioxide tells about the sp hybridization. We can also determine the hybridization using the structural formula technique, since the carbon molecule is attached with the 2 oxygen atoms at both sides using only single sigma bond. So the number of sigma bond will be 2, which corresponds with the sp hybridization. What is the bond length of carbon-carbon bond in benzene? The bond length of carbon-carbon would be 0.139. Let me remind you this, that 0.154 carbon-carbon bond is available in case of alkane. 0.134 will be applicable for alkene. 0.120 is applicable for alkyne. On the other hand, the number between 0.154 and 0.134, it is 0.139, which is due to resonance of the pi electrons within benzene. The bond angle, the bond length gets a bit higher than usual, which is 0.134. We have also another different carbon-carbon bond length in case of graphite, which is 0.142 nanometer. Which type of hybridization occurs in tetracarbonyl nickel? To determine the hybrid orbital number, we have to look at the ligand number. Here we see the number of ligand is 4. So the hybridization would be what? sp3. Here, as we can see, there is also sp2d, there is also sp3. Then what will be the answer? Actually, it depends on the atom. Normally, the atoms with higher number of electrons do not tend to empty its earlier shell, that is 3d subshell, for the acceptance of electrons from ligand. Okay, so the answer here would be sp3. What is the bond angle of boron trichloride? Yeah, that's what I was talking about. For boron trichloride, the bond angle would be 120 degrees Celsius, 120 degree, not degrees Celsius, 120 degree. Why? Because it shows sp2 hybridization. So the answer would be D. Which type of hybridization is present in the carbon atoms of CH3CN, that is methyl cyanide? Okay, in first carbon, the hybridization would be sp3. Why? Because it is bound with hydrogen and carbon using single bond, and it got 4 single bonds. But here, this carbon got only 2 single bonds. What is the structure? The structure would look like this. Here, the sigma bond is 2 in number. So for 2, you will get only sp hybridization. So the answer would be sp3 and sp, which is option D. In this compound, the number of non-hybridized p orbital. Look, the non-hybridized p orbital is responsible for pi bonding. Now you have to calculate number of pi bond to determine the number of non-hybridized p orbital. So the number of pi bond here is this one, and in carbonyl group. So there is 2 non-hybridized p orbital that participated in pi bond formation. So someone might think that if it is 2 or if it is 4, because both of them are in options. Both of them are in options. Basically, this carbon and this carbon both have non-hybridized p orbital to allow sidewise overlapping. Okay, that's why the number of pi bond is 2, but the number of non-hybridized p orbital would be 4. It would be the double of pi bond. So the answer would be C. Which one is different from others in hybridization? Okay, let's determine the hybridization of all. This one is sp3. Looking at the structure, we can tell that this one is sp2. So certainly this is what is making difference. pH3, hydrogen sulfide, all of them are sp3. All of them are sp3. Okay. The only example which is different is boron trichloride. What is the hybridization of chlorine in phosphorus pentachloride? This is a very important question. For phosphorus pentachloride, if we even look at the structure, okay, just think about a single chlorine. This is phosphorus trichloride, but look at the chlorine. It got 3 lone pair electron and 1 sigma bond. 3 lone pair, 1 sigma bond. In together, we get 4. 4 represents sp3. So the hybridization will certainly be sp3. How many lone pair electrons and bond pair electrons are there in the valence shell of central atom of phosphorus trichloride? Okay, look, phosphorus got 5 electrons in its valence shell. It donates or it shares electrons with 3 chloride atoms. So it certainly have 2 lone pair electrons and 3 bond pair electrons. Now they are asking about lone and bond. So first it would be 3, next it would be 2. But the option here, oh, actually, sorry, they are asking about lone pair first. They're asking about lone pair, rather later bond pair. So number of lone pair would be 3. Number of bond pair would be 3. This is the bond pair, and this is the lone pair. So the answer will be D. How many sp3 hybrid orbitals are formed in the process of sp3 hybridization? This is a very easy question. This is the precondition of hybridization. That is, the number of orbitals taking part in hybridization is equal to the number of generated hybrid orbitals. What is the shape of sp hybridized molecule? It is linear. Next, how many lone pair electrons are there in the central atom of xenon difluoride? If you can remember, I have already demonstrated their structure, and the structure looks like linear pattern, and the fluorine, since they have only 2 fluorine, the xenon have 3 lone pair electrons left in its valence shell. So the answer would be 3. Next, in which compound of the following is the effect of lone pair electrons are more? Effect of lone pair electrons would be more in case of more lone pair electrons. Here, nitrogen got only 1 pair of electron. Here, in water, oxygen got 2 lone pair electrons. So the effect of lone pair electron would be more in case of water, and it is also responsible for the reduced bond angle of water, which is 104.5 degree. So the answer would be B. What is the shape of ammonium ion? This is tetrahedral. This is not pyramidal. This is tetrahedral because it got sp3 hybridization without any lone pair electron. Which compound has the highest bond angle? I think the one with sp hybridization, as the bond angle becomes 180 degree. Hybridization of the central atom of carbon dioxide. central atom of carbon dioxide, hybridization is sp. Which compound has the least bond angle? 107, 104, actually 104.5, 104.5, it is 94, and certainly boron trihydride would show higher bond angle than phosphine. Why? Because boron is placed immediately before. Boron is smaller than phosphorus, and boron got lesser valency than phosphorus. So in this situation, the answer would be phosphine. Anyway, for boron trihydride, what would be the bond angle? Here, the hybridization is what? The hybridization is sp2. For sp2, the bond angle becomes 120 degree. So the answer would be phosphine. Which compound has larger bond angle or greater bond angle? Certainly boron trichloride. Why? Because it is sp2 hybridization. sp2. For sp2, the bond angle becomes 120 degree. In which of the following changes does the hybridization of the central atom remain unchanged? Okay. Here, as we can see, in which of the following changes does the hybridization of the central atom remain unchanged? So the pairs should have same hybridization. If we think about this carbonium ion, for carbonium ion, the hybridization becomes, let's calculate for carbonium ion, it becomes like this: half into 4 plus 3 minus 1 plus 0, okay, which is equal to 3, right? On the other hand, CH3I, that means carbon is using its forehand, and the hybridization would certainly be sp3. So the hybridization does not match. Here it is sp2, here it is sp3. Again, for this one is sp2, but this one is sp3. How did I determine that? Look, half into 3 plus 4 minus 0 plus 1. Okay, this is the way to determine hybridization for an anion. Ammonium, it is sp3. For ammonium, it is still sp3. Why? If you just calculate it, you'll find it, because the lone pair electron here is also being considered, and the lone pair becomes a coordinate bond. Still it is considered, because we have to calculate both lone pair and the coordinate bond in case of determining hybridization. So the answer will be option C. If the dipole moment of AB3 molecule is 0, if the dipole moment is 0, then what type of hybridized orbital will be used by A while being bonded with B? What type of hybridized orbital will be? If there is no dipole moment, we can assure that there is no such thing called lone pair electron in the structure. For without having any lone pair electron, the hybridization would certainly be sp2. Okay, while being bonded with B. This is actually nothing about lone pair electron. You can easily predict that sp2, because the number of hybrid orbital is or the number of sigma bond would be 3. The number of sigma bond would be 3, and the sigma bond represents the hybrid orbital, and no lone pair electron is there because no dipole moment. Okay, which one of the following has a pyramidal structure? Pyramidal structure is present in where? In sp3 orbital, but having a lone pair electron. Okay, let's have a look at this. Bromium trifluoride. It is an interhalogen compound, and bromium got not three actually. Bromine, it's not bromium, it's bromine. Bromine trifluoride. Bromine got 7 electrons in its valence shell, and it shares 3 with 3 fluorine. So it certainly have 2 left, right? 2 lone pair electron. For sulfur, it doesn't have any more lone pair electron, but it actually no lone pair electron. It is occupied with all oxygen. In this case, oxygen sulfur, the structure would look like this. Sulfur binds with 2 fluorine and oxygen, but we know sulfur got 6 electrons in its valence shell, and we only got a count of 1, 2, 3, 4, so 2 left. So lone pair electron number is 1. As I have already mentioned, that pyramidal structure would be found in case of sp3 hybridization with a lone pair, not without, with a lone pair electron. Now, if we look at this molecule, we will find that the number of hybrid orbital would be 4. How? Because the number of sigma bond is 3 and the number of lone pair electron is 1. So together the number becomes 4. 4 means sp3, and there is a lone pair electron. So it is an sp3 with a lone pair. So the structure becomes pyramidal. So the answer here will be OSF2, or sulfur oxyfluoride. The shape of boron trifluoride ion. We have already determined its hybridization earlier, which is half 3 plus 4 minus 0 plus 1, which is 4 plus 4, that is 8. 8 divided by 2, 4, so it is sp3. And now, if there is any lone pair electron, boron contains only 3 electrons, so there is no scope of having any lone pair electron. So what would be the structure of a molecule having sp3 hybridization without any lone pair electron? The shape will be tetrahedral. The answer will be tetrahedral. Which one of the following ions have a tetrahedral structure? As you can see, tetracyanide, nickel tetracyanide. Here, cyanide is a very strong ligand which will push away the electrons from the immediate D shell, and it would result into sp2d structure. sp2d would not be tetrahedral, rather it would be square planar. Similar in case of tetraimine copper. For hydronium and for ammonium, we have to consider hybridization as well as lone pair electron. In case of hydronium ion, lone pair electron is still left. One lone pair electron is still left. That's why the shape, instead of tetrahedral, it becomes pyramidal. But in case of ammonium, there is no lone pair electron. That's why, because of sp3 hybridization and without any lone pair electron, it becomes tetrahedral. The order of bond angle of ammonium. Okay. Ammonia got a bond angle of 107. Since ammonium have a lone pair electron, it becomes 109 degree 28 minute, which is because of its sp3 hybridization. What would be the case for NH2? Here the hybridization would be half into plus 5 plus 2 minus C plus 1, which is also sp3. For sp3, what will be the bond angle, or which one will show the larger bond angle? This is also sp3, this is also sp3, this is also sp3. But as we all know, the lone pair electron of nitrogen here, causes the distortion of its shape and result into 107 degree bond angle. If we remove or take away one hydrogen from ammonia, then the bond angle is supposed to be get larger than 107 degree. It would be like it would not be greater than 107 degree, rather it would be less than 107 degree. If we take away hydrogen, then all of them would stay equidistant from each other. As a result, the bond angle, the repulsive force of the electrons, lone pair electrons and the bond pair electron will certainly increase, and it will push them towards each other. As a result, the bond angle would get decreased. In this case, so the answer would be D. This one is with the highest bond angle, is one in the middle, and the amine group shows the least bond angle among these three. Potassium superoxide, aluminium oxide, barium oxide, nitrogen dioxide, nitronium, in fact, which one contains lone pair electron? Okay, in this case, if we draw the first one, oxygen certainly have lone pair electron. Oxygen gets bound to each other using this, but still they have lone pair electrons left, right? These lone pair electrons get attracted. Actually, these lone pair electrons are responsible for the negative natures of oxygen, or electronegativity would compel them to attract or pull any cation nearby, which is potassium in this case. So in this case, we can see oxygen have plenty of lone pair electron. So the answer would certainly be potassium dioxide, or potassium superoxide. In rest of the options, they gets occupied, they gets used up, utilized by remaining members. Okay, let's move on to the next question. In chlorate ion, what is the hybridized state of chlorine atom? Okay, actually, we don't have to go for the whole structural formula to determine this, because just if we write down this, then we will get the structure of chlorine and the lone pair of electrons along with it. So total number of lone pair electron here, as we can see, 3, and sigma bond is 1, so it will be 4, and the hybridization will be sp3. Which one of the following has a geometric structure like that of nitrate? Okay, now we have to determine the hybridization of nitrate to determine its structure. Okay, for nitrate ion, we can write this way. Okay, so it becomes 3, which is sp2. This is sp2 hybridization. What are the remaining one? For chlorate, what will be the hybridization? Half into 7 plus 0 minus 0 plus 1. So the hybridization will be, this is equal to 4, right? This is equal to 4, so the hybridization will be sp3. Again, for sulfate, half into 6 plus 0 minus 0 plus 2, which is also equal to 4, that is sp3. SO3, that is sulfur trioxide, half plus 6. Nothing else can be written here, because this is nothing. This is not no monovalent atom here, not a cation, not an anion. So the it will be equal to 3, and the hybridization would be sp2. As we can see, sp2. Here we have also got sp2. What about the last one? For the last one, chlorine got 7 electrons in its valence shell, 3 monovalent atoms. So the result would be 5, and for 5 we will get sp3d. So the atom or the molecule which have similar hybridization to nitrate is sulfur trioxide, hence their structure would also be similar. In which of the following changes have both hybridization and geometric structure? In which of the following changes have both the hybridization and the geometric structure changed? We have to find out the pair where the hybridizations are different or the structures are different, right? Okay, here CH4 means sp3, C2H6, this is also sp3, isn't it? Because both of them are alkane. Boron trifluoride, this one is sp2, boron tetrafluoride. Is this sp2? No. No, yeah, I can calculate this way, half into 3 plus 4 minus 0 plus 1, which is equal to 8. Exactly, this is equal to 8 divided by 2, which is 4, So for 4, it becomes sp3. As it is sp3 and this is sp2, the shape and the hybridization, both of them will be different. So we got our answer, which is B, option B. In case of the other options, the answer will not be the shape might be changed, like water shows bent structure while the hydronium ion shows the pyramidal structure, yet the hybridization is same. In case of ammonia and ammonium, for ammonium hybridization is sp3, for ammonia hybridization is sp3. Only the geometrical structure changes here. In these two, only geometrical shape is different. Both geometrical shape and hybridization is different in case of option B. Which pair has a similar structure? This is a certain type of question where you have to find out two hybridization together. Here, I think if you practice a lot, you will be able to determine those by just looking at them. See, even at this moment, I think you can easily tell that boron trichloride shows sp2 hybridization and bromine trichloride would show sp3 hybridization. How? Because bromine have a lone pair of electron after binding with 3 chlorine. So the number of sigma bond is 3 and the number of lone pair electron is 1. So together it will be 4, which will be responsible for the sp3 hybridization. For nitrogen trifluoride, it is sp3. For boron trifluoride, it is sp2. For ammonia, sp3. For nitrate, sp2. For boron trifluoride, sp3. For ammonium, sp3. Since both of them show similar hybridization, so their structure would also be similar, which is tetrahedral. Okay, which one is the geometrical shape of ice? We have already solved that, which is rhombohedral. In the homologous series CnH2n, the bond angle of HCH will be homologous series of CnH2n, that is alkene. For alkene, the bond angle would be 120 degree. Why? Because there is sp2 hybridization. In which of the following compounds are the electron pairs of the central atom not arranged in a tetrahedral manner? I mean, which is not sp3. Okay, let's find out the shape. For H2O, this is bent. In which of the following compounds the electron pairs of central atom not arranged in a tetrahedral manner? For stannous chloride, for ammonia, for PF3. For ammonia, it is pyramidal. For phosphorus trifluoride, it would also look like pyramidal. For stannous chloride, what is the hybridization here? The hybridization would be excuse me, the hybridization would be sp2. For sp2 structure, with a lone pair electron, it would not be trigonal. It would rather be bent shaped. The shape would remain bent or angular instead of the trigonal structure, okay, because of having a lone pair electron. Anyway, we can say that the hybridization here is sp3, hybridization here is sp3, hybridization here is sp3. So basically the question is ill-worded. It does not explain actually what it meant. It meant actually that in which option there is no sp3 hybridization. I mean, there is no 4 orbital. The tetrahedral fashion with this, they tried to mean that 4 hybrid orbitals will be generated. But as we can see, option A, option C, option D, all are sp3 hybridized. None of them are tetrahedral. And stannous chloride, on the other hand, is of sp2 hybridization, and its shape would be bent instead of trigonal. So instead of going for the tetrahedral pattern, here the answer would be stannous chloride because of having different hybridization. Okay, the question is not properly transcribed. It would actually mean that which one does not show sp3 hybridization. What is the angular distance of a bond in a tetrahedral molecule? Angular distance of a bond in a tetrahedral molecule should be the standard one, which is 109 degree 28 minute. The process of mixing of multiple orbitals of different energy in the valence shell in order to form same number of orbitals with equal energy is called hybridization. Basically, this is the definition of hybridization. What will be the shape of molecule if there is sp3d2 hybridization? sp3d2, you are getting 6 hybrid orbitals. For 6 hybrid orbitals, the shape would be octahedral. So the answer would be B. How many hybrid orbitals in the central atom's valence shell make central atom's valence shell make the molecule pentagonal bipyramidal? Just think about penta, think about bi. So penta and bi, if you add it up, it would have 7 orbitals, which is sp3d3, right? The answer would be A. Examples of sp2 hybridization. First one is the sp2 hybridization. Methane, carbon tetrachloride, ammonia, all of them show sp3 hybridization. Which of the following compounds contain sp2 hybridized carbon atom? sp2 hybridized carbon atom will be present in alkene. Here, this one is alkene, okay? Which hybridization occurs in carbon atom of the carbonyl radical? See, this is the carbonyl radical where carbon got 3 sigma bond and no lone pair electron. So the answer would be sp2. The hybridization of carbon in HCHO, same, just determine that, which is sp2. What will be the HOH, that means water, which is 104.5. Oh, basically it asked about, it is not about water, it is about hydronium ion. See, that's how we can do a mistake. For water molecule, oxygen have 2 lone pair electron, but for hydronium ion, oxygen only have 1 lone pair electron. Both of them show sp3 hybridization, but here the shape is bent and here the shape is supposed to be pyramidal. Okay, here the bond angle becomes 104.5 degree, but the bond angle over here would be 113 degree. So the answer here will be D. Okay, going to next question. Ammonium, ammonia, ethene, ethane. Which statement is similar in terms of these 2 changes? Okay, let's see. Ammonium shows sp3, ammonia shows sp3, but the shape gets changed. Here shape is pyramidal, instead here shape is tetrahedral. Here it is sp2 hybridization, this is sp3 hybridization. Okay, now let's see. Lone pairs of electrons are formed in the product. No, no, not in both cases. Only happens for option A. This option applicable for only this one. A change in the oxidation state of the element has occurred. No such thing. It occurs only for option A, not for option B. I mean this one, not for alkene and alkane. Decrease in bond angle occurs. Here we can see the bond angle would be 109, but Here the bond angle is 107. Here the bond angle is 120, but here the bond angle would be 109. So in both cases, only one thing is common, which is the decrease in bond angle. So we got our perfect answer, which is C, decrease in bond angle. Pi bonds are eliminated in case of the alkene, not in case of ammonium or ammonia. In which of the following compounds the carbon atom marker star is sp3 hybridized? Okay, for sp3 hybridization, you have to have at least 3 sigma bonds. So we can see here this carbon have 3 sigma bond. No, for sp3 hybridization, carbon needs to have 4 sigma bond. 4 sigma bond. So this is actually sp2 hybridized. This is also sp2 hybridized. This is also sp2 hybridized. This carbon is actually sp3 hybridized because all of the four hands of carbon is utilized individually. What is the ratio of bond pair electrons to lone pair electrons in xenon oxyfluoride molecule? Okay, for xenon oxyfluoride molecule, ratio of bond pair and lone pair electron. Okay, if we demonstrate the structure, it would look like this, like xenon bound with 2 fluorine, again xenon bound with an oxygen. Now we are saying that 1, 2, 3, 4 electrons are utilized. Still xenon have 2 lone pair electrons left. So bond pair 4, lone pair 2. So the ratio would be the ratio of bond pair to lone pair. So bond pair is 4, lone pair is 2. So it will be 2:1, which is 2. Okay, the bond pair is 4, the lone pair is 2. So the ratio would be 2. What is the number of FIF bond angle of 90 degree in interhalogen compound iodine pentafluoride? What is the number of FIF bond? This is a crazy question. I mean, you got iodine and you got 5 fluoride at the 5 corner. Now you are asking about the angles. How many angles of 90 degree will we get? Actually, we will get 5. We don't get all the angles at 90 degree. One angle becomes 120 degree as well. So in case of this molecule, in case of iodine pentafluoride molecule, what kind of hybridization would be there? As we know, this iodine also have a lone pair electron. Since all iodine have 7 electrons in their valence shell, so one single lone pair electron will also be there. What would be its hybridization? Its hybridization would be, since it have totally 5 sigma bonds, 5 sigma and 1 lone pair, so they got 6 hybrid orbital, right? 6 hybrid orbital. For 6 hybrid orbital, the shape becomes octahedral. The shape becomes octahedral. Now, if you draw an octahedron, actually, it will not be an octahedral shape. Why? Because for octahedral shape, you cannot have any lone pair electron in the central atom. Since it have a central atom lone pair electron, that's why the shape would get a bit distorted. Instead of octahedral, it would be actually, what is octahedral? Tetrahedral bipyramidal, right? Instead of tetrahedral bipyramidal, it would be tetrahedral pyramidal. It would look like a tetrahedron pyramid. So let's have a look at the structure. How would it look? Instead of tetrahedral pyramidal, hexahedral pyramidal, if we consider that, so basically the structure will be responsible for at least 8, though the structure will be distorted from the octahedron point, still it will have 8 points that will be associated with each other. So for 8 points, 2 angle would be 90 degree, 1 angle would be 90 degree. I mean, what is the number of FIF bond angle of 90 degree? How many 90 degree bond angle would be there? I think this one will be 90 degree, this one will be 90 degree, this one will be 90 degree as well, and this one will also be 90 degree, and also this one will be 90 degree, and this one will also be 90 degree. But here we get 2 in each sphere, 2 in each pyramid. So in together we will get, I mean, 4 at this level and 2 in both sides, 1 at the top, 1 at the bottom. So together we will get a bond angle of 90 degree at least 8 times. 4, 2 at the above, 2 at the below. So total number of FIF 90 degree would be 8 because of its structure. Okay, which of the following compound has a triangular shape? The triangular shape will be available for sp2, sorry, this will be sp2. This one is sp3, this one is sp3, this one is sp3. A carbon with sp hybridization forms what type of bond? Carbon with sp hybridization. Sp hybridization means it should have at least 2 pi bond and a sigma bond. 2 pi bond and not 2 sigma bond. Why? Actually, it will be 2 sigma bond. Why? Because the carbon atoms will be connected with each other using 1 sigma bond, but one hand is still left to bind with hydrogen. So number of sigma bond will be 2 and number of pi bond will also be 2. So the option will be C. Which of the following compound has lone pair electron? This one do not have any lone pair electron. This one do not have any lone pair electron. Boron trichloride do not have any lone pair. Boron trichloride has lone pair electron, but it has lone pair electron in case of chlorine. Actually, the question is asking about a central atom that lacks a lone pair electron. So boron do not have any lone pair electron. We leave this question. Beryllium chloride. Beryllium does not have any lone pair electron too. But this ammonia is a celebrity compound which is very known to us having a lone pair electron. What is the shape and hybridization of ammonium ion? We have already solved that almost 4 to 5 times, which is tetrahedral sp3. How many new orbitals can be created in dsp2 hybridization? dsp2 means The sp2 means 4 orbital or 3 orbital? 4 orbitals. So the answer will be C. What is the shape of ammonia molecule? Already solved that, tetrahedral. What is the shape of beryllium chloride? Beryllium chloride shows sp hybridization with linear structure. So it will be C. How many lone pair? This is not lone. This is not lone that you have took from bank. This is actually lone. It means single. How many lone pair electrons and bond pair electrons are there in valence shell of central atom of phosphorus trichloride? It's very easy. Phosphorus have 5 electrons in its valence shell, so bond pair is 3, lone pair is 1. The answer would be this, 1 and 3. In which of the following sp2 hybridization exists? This is graphite. This explains its electrical conductivity. In which of the following do the orbitals of carbon atom undergo sp3 hybridization? sp3 hybridization, we'll find that in where? Alkane. What is the value of angle between sp2 hybridized and unhybridized orbitals of carbon atom in CH2CH2? Okay, this is a good question. In case of alkene, the hybrid orbitals are in 150-degree bond, but the hybrid orbital and the unhybrid orbital stays at 90 degree. They are again responsible for the pi bonding. Hybridization of oxygen atom in water molecule is certainly sp3. In which of the following compounds sp3 hybridization is present? In boron trichloride, it would be sp2. Boron trifluoride, same. Ammonia, sp3. So the answer is C. What is the hybridization of sulfur in sulfur hexafluoride? For sulfur hexafluoride, the hybrid orbital number would be 6 plus 6 minus 0 plus 0, which is 6. For 6, we will get sp3d2. sp3d2. So the correct answer will be B. Which is not correct? Beryllium chloride, sp, boron trichloride, sp2, boron tetrahydrate, sp3, ammonia, sp2. Which one is not correct? This one. This is sp3. What is the shape of phosphine molecule? Phosphine molecule have sp3 hybridization. It got 1 lone pair electron. Hence, the shape would be pyramidal. But basically, it would not be it would be trigonal pyramidal, not trigonal. Trigonal pyramidal, not trigonal bipyramidal. Trigonal bipyramidal will be applicable for sp3d. I mean, where there is 5 orbitals, it can be trigonal bipyramidal. Where only 3 orbitals are there, it can be trigonal, where sp3 tetrahedral. But trigonal pyramidal is for sp3 with 1 lone pair electron. What is the HSH, bond angle in H2S? This is a very important information that you need to remember, which is 92.1 degree. In which compound geometrical shape of orbital hybridization is trigonal planar? Trigonal planar means hybridization should be sp2. Let's find out. Leave this. This is not a covalent compound. Carbon tetrachloride shows sp3 hybridization. Phosphorus pentachloride shows sp3d hybridization. Aluminum trichloride. Aluminum trichloride is a bit ionic, but it shows covalent nature as well. Here, as we can see, the structure of aluminum chloride, if we look at it, it might look like sp2 hybridization. Why? Because it got free chlorine in free hand. That's how it shows sp2 hybridization. And for sp2 hybridization, the shape should be trigonal planar. Okay. What is the angle between sp2 hybridized orbital and unhybridized p orbital? We already solved that, which is 90 degree. Hybridized orbital maintain a certain angle between them, but hybridized and unhybridized are at right angle to each other. So with this, our questions came to an end. So what I want to recommend you for hybridization, that you will certainly find a chart in your book where different kind of hybridizations are explained all together. You will certainly be able to recognize that chart once you go to book. There is a box where number of lone pair electrons, number of orbitals are mentioned, and according to that sample, some examples are also given. I recommend you to practice from that, and also try to practice questions enough so that you gain certain level of skill, so that you can easily diagnose or determine the hybridization just looking at that compound. Anyway, best of luck.